Hi guys, this is Roland and it is tutorial time again. I've been away for a while because I was very busy. I was actually building a new website, rebranding my channel. So if you follow me for a while, then you probably realized that I changed the branding and the name of my YouTube channel. I was graphic in motion for nearly 13 years now, but now I decided to change that name into Node Connector. And that's because my focus changed. You know, back in the days, I was focused on creating motion graphics with After Effects, and now I'm more into the more advanced 3D stuff using Houdini. And that's actually what we're going to do today. So we are going to do a build-up animation in Houdini. Let's check out the final result. So this is the animation that we are going to build. We will create this build-up animation using a Procedural KineFX Rig, because I think that this setup is really, really versatile and you can really create a lot of different build-up animations when you build this system one time, then you can adapt it and change it. Let's quickly go through the project. So it's actually pretty simple. So in the beginning, we will just create this little setup where we voxelize our object. Let me shift to the scene view. So this will be our final thing where our object is turned into these voxels, so these cubes. And then we are going to build a procedural rig, and this will include connecting some points. So we will just use the points from this, and then we will connect them, and then we will create a rig. So some paths that actually work as a rig, and I should just hide the other objects here. And then we will prepare this rig and actually turn it into a KineFX rig that we can then just animate. And we will use a Falloff to do that. In this case, I'm using the MOPs Falloff tool here. If you don't have MOPs installed, I would really recommend to do so. So stop the video and go to their website, which is linked in the video description. It's a collection of free plugins that are very useful if you do motion graphics stuff in Houdini. There are, of course, other options how you can create such an animating fall-off as we do here, as you can see. So this is what will drive our rig in the end. You could do this with an infection solver, or you could also do it with a pyro spread solver. All these options are built into Houdini, or you can animate a gradient or a fall-off. But I will focus on the MOPs Spread Falloff because it is a very good tool and it will make it way easier for us, this whole process. And then we will do a little bit of VEX. So we will build our custom controls here to animate finally our KineFX rig. And that will look something like this in the end. So actually, if I take a look at this here, so this will be the final result of the animation. So here I just got rid of the primitives, which is actually not really necessary. But that's what we are going to create. So this procedural growth here. And yeah, then in the end, we can decide whether we want to send this point cloud into Solaris and instance the cubes on directly in Solaris, or you can, of course, just copy points to this here and use it like this. And the cool thing is that we have this fall-off attribute that you can also use for shading. You can blend between two different materials, and that's exactly what I did with these two materials. If you take a look at that here, blending between this yellow and between these emissive bluish cubes here. I will not go through the Solaris side of things here. So this is my Solaris setup where I'm blending between these shaders. You know, it's a very simple setup actually. But if I show the render process of every tutorial, it gets kind of repetitive because it's always the same. You can download this whole project file on Patreon. So if you want to check it out, if you want to reverse engineer it, then please check Patreon. The link is in the video description. There you will find exclusive tutorials and full courses for Houdini. But now, without further ado, let's jump into a new project and let's get started. I'm in a fresh scene of Houdini, and now we will create our geometry network. And this will be our KineFX build setup. So let's dive inside here and let's start by bringing in our rubber toy. You can, of course, use whatever object you want. And we are crashing when I'm building. This is very interesting. Okay, I'll restart this and be back in a moment. Good, I'm back. So this was really the first time since I use Houdini that it happened to me that I crash when I add one of these test geometries like the rubber toy. So let's see what other surprises we will get today. Maybe today is not a good day. So since I upgraded my system to Windows 11, which I had to do because of the end of Windows 10, some things are, a little bit difficult. But let's see. I will go into my geometry network and add the rubber toy if it is still working. Yeah, here we go. Okay, so as I said, you can use other objects. Just be a bit aware of the scale. If you have an object that has a totally different scale, then you will, of course, need to apply or change your settings. Now, to turn this into points, we can just grab points from volume node. And this will add an even or in a grid distributed array of points, as you can see here. So this is pretty good because this way we get this nice voxel setup. If you want to have something irregular, maybe if you want to use the Voronoi fracture here, then you can of course also jitter these. But in this case, I will leave it like this, and I will turn down the point separation to 0.05. And if you now copy cubes to this points, then you have this voxel thing. So let me quickly show you this. I actually don't need this right now, but this is just for demonstration, how you can set this up. If you do it like this, I would recommend that you pack and instance these. They are, of course, way too big, but if you copy the point separation value, so copy this parameter and paste it into the uniform scale here as a relative reference, then these are linked, and no matter what you put in here, this will always update and you have a nice voxel setup. We actually don't need the cubes right now. We only work on the points, but I will just leave this in here as a reference. Now let's continue working on our points. What we need to do is to create a rig. We need some kind of a connection in between these. And therefore I want to use the find shortest path node. But to create a find shortest path, which will actually just create a path from one point to the other one, and you can control this a little bit as we will see in a moment. But before you can do that, you need some kind of a connection between the points. But let's do it step by step. First of all, we need two groups. We need a start group and an end group. So I will create these and I will add a group node to create my start group. This should run over points, of course, because we need points. And I will rename it to start. I want to use the bounding region here and just set this up. Just something like that, that I have a few points here to start with. That should be fine. Maybe I will even reduce it a bit. Yeah, that's okay. So this is my start group. And now I want to create an end group. And in my end group, I actually want all the points that are not in the start group. And I can do it with another group node. But this time we will tell Houdini it should just take all the points except the points in the start group, and you can do it like this. So let's call this end group and let's run it over points. And now we can just tap it like this. So with this exclamation mark, I think it's called, and then start. And now we get all the points except these from our start group. And this is the end group. Great. Now we need to find a way to connect all of these pieces so that we have a primitive running through all of them. It should not be one primitive, but some kind of a line. And therefore you can use the connect adjacent pieces node, this one here. And if you set it up to adjacent points, then this will create a very dense connection. So if you middle mouse click here, you see that we have now nearly 350,000 primitives. That's quite a lot. And that is because by default, the search radius is okay for us. You know that the separation is here at 0.05. So we could put this in here to avoid any additional connections that we don't want, but sometimes this can cause problems. But let's take a look. Now we are down to 90,000. That's already way better. But I can also reduce this maximum search points here. So I can say maybe 24. And this really depends on your mesh and on your distance and also on the type of object, of course. So if I reduce this down, so it is very obvious if I set it to 6, because then we will get this very regular grid. And at some point, you will get a problem that not all of the points are able to connect anymore. But you really want to make sure that all of your points are somehow connected with each other. So let's increase this here just to make sure that we have enough connections. And I think with 12 and this search radius, we should be at a secure spot. We will see this in a moment. Now we can use the find shortest path. And the find shortest path is really a cool node. And if you never used it, then maybe check some tutorials on YouTube about this. You can do really cool things with it. In this case, we will just set our start and our end group. And then we have to specify what this should really do. And we want to create a path from any start point to each end point. So it will try to just connect everything here from our start to the end. And that's what we will get, as you can see. So it looks pretty cool. Right now it is very symmetric and regular, but we can change this in a moment to make it a little bit more organic. And this will influence our build-up later on. So everything that you do now, from now on, will have an influence on your build-up animation later. There's one problem with the find shortest path. If we middle mouse click, you see that suddenly we are here with 95,000 points, and before we had only 7,199. So it creates additional points, and you want to avoid that because you cannot turn something like this into a working rig. So let's do a fuse node here, just to make sure that we are fusing all of these additional points together. And you see now we are back to this standard value here. That's good. And you can also put in a polypath, because the polypath will just join some of these primitives together and make longer paths. So let's add this in. And if you take a look at the primitive count, here we are at 7,147. And now we are at 4,342. So it means that we have now longer paths. It connected some of these paths, and that can be helpful to create our rig later on. So if you would continue like this, you will get a very regular build up because, as I said, it's pretty symmetric, this structure. So I want to make this a little bit more organic by adding a cost attribute. The find shortest path has an option here, the path cost, and you can use a point attribute, and you can name this however you want. I will call it cost attribute. And it complains because it cannot find this attribute, and we can now, let's say just here after the connect adjacent pieces, create this by using an adjust attribute float node. So let's create a cost attribute. It should be on the points, and we want to use a noise here. And I want to visualize this for now that we see what we are doing. You see now we have cost attribute. Wherever it is purple and blue, the values are low, and red is a high value, and that means you can think of this like a resistance. So if the path tries to find its way to its end point, then it will encounter some resistance along its path now due to this cost attribute. So wherever the point or the value is low, then it's easier for it to get a path, and wherever the value is high, it will have a little bit of a problem and will try to avoid these areas more. That's actually what's going on here. So now we will set the size down here a little bit just to get a bit more variation in here. Maybe this is a little bit too much. Let's set it to 0.25. Yeah, this looks a little bit better. And you could now, of course, also remap this and do all sorts of things with it, even increase the value that the resistance becomes bigger. But for now, I think that this is okay. So if I turn off this here, and now you see it's not that regular anymore. So there is no symmetry anymore in here, and it is a little bit more organic. So that's what this is doing, and we can later on also use this to influence the spread of our falloff. But before we do that, it's time to turn this into a working rig, and therefore we will use a rig doctor. This is a KineFX node that will turn any path that has some kind of an order, some kind of a connected primitive into a rig. Now it's time to introduce our MOPs Falloff tool. And as I said, if you did not download the MOPs Falloff or the MOPs tools, then I would recommend to do so. It's really handy. And we want to use the MOPs Spread Falloff. The MOPs Spread Falloff does what it says. It creates a falloff value and spreads it across your mesh or your points or whatever you need. In this case, we will run over points. And to make this work, we will use a start group. So it needs a start group, and then it will spread from there. Unfortunately, if we middle mouse click, you see that we somehow lost our group. So we created groups up here, but with the find shortest path, these are gone. So we have to somehow bring them back in here. Now, I will just bring them back in here. Yeah, I can bring them down here, I think, directly. Let's see. I will use a group transfer to do that. That's very similar to an attribute transfer where you can just transfer groups. So let's do it like this. And I want to make sure that I only transfer the group start, which is a point group. And I want to transfer it from up here where we still have it. You see here at the attribute just fold, here are my groups and then start. So let's just go over here, hold on Alt and bring it in to this here. Yep. And this should work. And you see now we have these points. So the thing is now sometimes you get a problem because we fused something and polypath, but in this case it looks fine. Just make sure that on the beginning of these paths that the right points are selected. And in my case, this looks good. If this is not the case, then instead of transferring the group, you may have to create just a new group to use in the MOPs Spread Falloff. That's also an option. Now let's specify the start point group here. Let's go to the MOPs Falloff and choose our start group. And now we can move to the Animate tab. And to see what this falloff is really doing, we want to activate the preview falloff here and activate or set the display flag to our MOPs Spread Falloff. The MOPs Spread Falloff will create a point attribute, a float attribute, and that is called MOPs Falloff here. We will change this to falloff because then it is a little bit simpler to do all the wrangles later on. So let's just change this name to falloff. If we middle mouse click here, you see we have now this falloff float attribute on our points. And if we change the spread, you see what it will do. It will just change the values. Now, if you take a look at this falloff preview, you see that the color purple or blue means that the value is 0, and the color white means that the value is 1. So we are creating a falloff from 0 to 1. And we can memorize this because later on we will also need this information when we build our rig animation. But first of all, let me introduce the cost attribute, because right now this spread is actually pretty regular, like a sphere more or less. And this will also create a very regular build-up later on. So this also has an influence. Now we actually determine how long our animation takes and how it will evolve through our object. So let's create an animation first of all. So a very simple animation. I will just animate this spread from 0. Let's create a keyframe by pressing Alt left click. And I will use now about 192 frames and set it to 1.2. So why do I set it to 1.2? That is because if I just set it to 1, you see that we do not reach all the points. And that has to do with the falloff width. And the falloff width is also a value that influences the look of your build animation. So if you take a look at the falloff width, right now, the area between white and between purple is actually the area where the falloff will where the buildup will happen, where all these little blocks will appear and be put together. If you want this to be a wider area, then you want to increase this, you see? Then you have a wider area where your buildup will happen and a lot of blocks will just pop on at the same time. But if you want to be this very narrow, so one line after each other should pop up, then you can reduce this and you will have a very small area here where the buildup is actually happening, and it will also happen way faster. So the animation of the single blocks will be faster. In this scenario, the 0.2 is actually a good value, so I really like that. And then if you animate this spread falloff, you have to add actually this falloff width to your spread, because otherwise it may happen that you do not get all the points fully evolved, and then also the animation will not run through. So let's set this to 1.2 and let's create a keyframe here. And I want to shift click this and just turn this into linear keyframes so that this is a linear animation. Now we can take a look what we have. This is our basic animation, and I should toggle the real-time switch here. Then we can see the real-time speed, as you can see. So this is the duration of my build-up, and that is actually pretty nice. But as I said, right now it is a bit boring because we have only a regular or spherical distribution here, or spreading of our value. And there is this option to add an additional cost attribute. Now, the cool thing is that we already created this up here. And as you can see down here, it is still available. So we can just use this. And this is very handy because now the find shortest path and the MOPs Spread Falloff will use the same cost attribute, and we will create the same resistance here for our spreading. And this way we'll get a way more irregular and more organic spread and build up in our object, as you can see here. Okay, so now it's time to turn all of that into an animating KineFX rig. And to do that, we have to do a little bit of coding, but I really will try to keep it as simple as possible and explain every step. So before we do anything here, before we set up our rig wrangle, I want to specify an axis. If you take a look at the rig doctor node here and activate its tool and zoom in here, you see, and actually there's one thing that I have to do, I forgot this, sorry. I want to initialize the transforms here. So if you initialize the transforms, then you have these local transforms here. If you don't do that, let me take a quick look. Yeah, then we don't have that. So it makes sense to initialize the transforms. I forgot this step. Sorry, that's very important. So now we have these local transforms here that we need to animate our rig. And I want to specify one of these axes. If you take a look here at these small white dots with these points here pointing in these directions, we can now specify at which axes our blocks should rotate when they are building up. And I want these to rotate around the x-axis, and I just want to specify this axis right away. So let's create a point wrangle here, an attribute wrangle that runs over the points. It's exactly the same actually. And I will just call this set axis so that we know what we are doing here, And we will use a very simple expression just to create this axis. We say v at axis because it is a vector attribute, and we want to specify our -1, 0, 0. And the -1 just has to do with the direction of the rotation later on. So I figured this out before that we need to use -1 here. So now I have my axis that is actually stored on all the points. And now we want to create our control so that our MOPs Spread Falloff will actually move our procedural rig. And therefore we will use a rig attribute wrangle. So that is important that you use a rig attribute wrangle and not a standard attribute wrangle, because otherwise this will not work. Let's use the rig attribute wrangle here. And I like to actually put in a null here because otherwise I always have these points in the viewport and they're a bit annoying. Could probably also turn them off somewhere, but yeah, I just use it like this. Then I can switch between these and get a better preview. Now we have to do a little bit of coding. So let's take a look at this code, or maybe I will just press Alt and E to bring up this separate window here. Then we have it in the middle here. Can make it a bit bigger. It's really not that complicated. So there are actually 3 functions that we want to use because we want to do 3 different movements. First of all, we want to rotate our cubes or our pieces. So we will use the pre-rotate function. I will just type these in now, all these functions, the pre-rotate function. Next, we will scale these, and there is the pre-scale function. And then we want to translate, so move these along a certain axis, and there is the pre-translate function. Okay, so let's take a look one by one. I will just deactivate the other 2 for now so that we don't create errors all the time. And let's take a look what the pre-rotate function requires. If I open up the parentheses, then this little helper here, this little help information comes up, and then I can take a look what I need. The same applies if you just put your cursor in here, but it has to be purple for that. So you have to open the parentheses so that Houdini recognizes that this is a function. You can press 1, and this will open up the help exactly for this function. So this is also very handy and very good. Now you see that there are a few options how you can use this function. And in my case, I want to use it on a matrix. So the first thing we need is a matrix. Then we need an amount that can be a float and an axis that can be a vector. Let's check out how we can get this matrix. So the matrix that we need is actually the matrix that our rig doctor creates here. So this local transform, this is the local transform axis of all of these points in our rig. And we can access that by typing in here for at local transform. So that's just the way to call these things. And then comma, and now we need an angle that is a float value and an axis that is a vector. I'm writing these now as variables here because I want to specify the variables right now. So we can create the axis right away because we already set this up in the last wrangle. So let's say our vector axis equals to v at axis. That's the attributes that we specified in the last wrangle. And now we want to create the float angle. And this is where we want to bring in the control or the animation from our falloff attributes that our MOPs falloff creates. And we can do this with a channel ramp function. So let's bring in a channel ramp function because then we can map the rotation of our objects between our value or on the value of our ramp. So our ramp creates values from 0 to 1, and then we can specify how much rotation we want on this 0 to 1 range. It will make more sense in a moment. So let's just put in here a channel ramp that is called rod for rotation, and we want to map this actually onto our falloff attribute that is called f at falloff. If you did not change this falloff attribute, then make sure that you just use whatever is in here. So if you didn't change it and there's still MOPs falloff, then you have to use MOPs falloff. If you changed it to something else, then of course use the right name here. Now, if we apply and accept here, we have to create, let's choose this wrangle here. We have to create these controls here by clicking the create parameters thing here. And now something should happen. If I come in here, you see that actually something is happening. So now we are creating an animation that with our falloff, we will rotate and fold our rig. But that's actually not what we want. We want it the other way around. So we want to unfold this. Now there are two things that you can do. You can go here and just invert this ramp. That's one option. Now we will have this unfolding effect. But to time this later on, it is better that the ramp shows in the other direction, in this one. And we can invert the MOPs falloff or the falloff attribute here by just subtracting it from 1. So we can say 1 minus this falloff. This will just invert it because, as I said, we are creating a value between 0 and 1 here. And if you subtract this from 1, you're inverting this. And this now creates this unfolding. So that's the first step that we want. The next step is that we scale this. So now we need our pre-scale function. So let's take a look at that. And let's also open up the parentheses here and let's see what we need. Here, we need a matrix. And then we just need a scale vector. So this is pretty simple to set up. Let's say for add, or actually just copy this, just copy this over here because it's exactly the same local transform. And now we just need a scale factor. So let's say scale here. And now let's just define this scale. This is also a float value scale. And the cool thing is that we can just use our falloff attributes directly here. So f at falloff, this would work. But let me show you this as it is now. So I just misspelled this here, falloff. Now we are just using this scale directly from our falloff. And this will work. Now we can use it like this. But if we want to have control at what point of our falloff the scaling should actually happen, or if it should be a little bit eased in, or it should pop up really fast, then we want also to be able to map this with a ramp. And we can do this, of course, by using a channel ramp function. So let's do a channel ramp again here and call this scale. And now we just want to set it over the f at falloff and just do it like this and create this. Oh, I misspelled this. So channel ramp. And now we create this control. Now we have our scale ramp. So what this does now is, let's go down here, that you can control at what point of our falloff the scale should happen. If I put this right away in the front here, then it will scale up pretty quickly. So you will see that now it will scale up very fast and then rotate. And we see this, of course, here on our ramps. And that's why I said it makes sense to keep this direction here, because then I can say, okay, I want to scale, and then it should start rotating. So this would be possible now to set this up nicely. And this will all happen between this purple and between the white color, as you can see. So now you have a pretty good control how your buildup will look. I definitely don't want it like this, so I may create something a little bit, yeah, maybe something like this. I will tweak this later on, but for now, let's see what this does. It will pop in, we have a bit of rotation here. Yeah, this doesn't look too bad. Okay. Now let's do the last one here, and that is the translate. Now on the translate, let's take a look at that, what this requires. So let's open up parentheses here to turn this into a function. It requires a matrix and a vector amount. Now, we actually don't have a vector amount. And let me quickly turn this off again so that we don't create any errors here. We need some kind of a vector that points along our path. So if we take a look at our polypath here, or at our find shortest path, if I now activate these normals here, you see that there is nothing on it. And if I middle mouse click, you see I only have position and I have no directional vector on these paths. But that's actually what I need. I need some kind of a directional vector to tell Houdini in which direction it should translate these points. And it's pretty simple to do. We can, before the rig doctor, we will just introduce an orient along curve. The orient along curve can create these vectors for us. So if we now middle mouse click, you see we have two vectors now, the up vector and the normal vector. So if I activate this now here, you will see that now we have a normal. This was the wrong one. This is the one that I want to activate. Now I have vectors that actually point in the direction of the tangent here. So that's what we are doing here. We don't need this up attribute. I will just use this tangent normal here. And that's what I can use now with my pre-translate. So let's take a look how we can set this up. Again, we need this matrix. So we will copy this over again for at local matrix, or for at local transform. And then we need our translate vector. And this is again a variable that we will now define. So we have a vector here that's called translate. And what we need first of all is we want to use our normal. So we can put in here at n, and we will multiply our normal with our falloff. But again, I want to map this falloff. So again, I want to use a channel ramp here. So let's use a channel ramp here. Let's call it translate. And in this case, I say translate amount. And I will just map this. And this time, again, I want to use the negative or the inverted falloff. So let's do again. We can also copy this over here that we don't have to type this the whole time. Just use this inverted amount here and close these parentheses. And then I want to add another control here, another slider that is like a scale value, so I can increase the distance here. So let's multiply this with another channel, but this time I use a channel float. And this will just be our translate scale. So I will just call this translate _ scale, and that's it. And now we can just close this and create all of these functions. Now let's increase this value a bit, and you will immediately see that something is happening. I will overdo this now so that we see what this is doing, just set it to a higher value. And now let's take a look what influence this has on our animation. And you see right now they are scaling up and then they are scaling back down. And that is what the translate actually does. And this can have a cool effect when you're doing build-up animations, because then these blocks will not just appear in their final position, but they will come from outside. If you combine this with the rotation and the scale, then it really looks as if they would, be put on each other. But of course, this is way too much. You can now reduce this to a small amount, something like, I don't know, we'll see this later on. So yeah, it's pretty much done. So what we can do now is just add a few cubes here so that we can see our final result. And as I said, so let's call this maybe out _ animate or rig animation. And let's add a few points here, and I actually can just copy this setup here because this is already set up so that it has the right size, because I put in here this reference to our particle separation, a point separation on the points from volume. And that's what we get now. So let's take a look at that. And you see now we have a pretty nice build-up animation. And now you can come in here and tweak this. So now it's time to really tweak this, to play with all these values. Now, if you have the feeling that, for example, this rotation is not enough, then you can always come here and again tweak this a bit. It's also an option to multiply the angle. I would be very careful if I do that, but you can do that by just multiplying this, for example, times 2. Then you would have a little bit more of rotation here, as you can see here. And again, as I said, you can always come in here in the fall off and just change the width, and then it will just create a bit of a different build-up. Let's take a look at that now. Now they will build up like this, and all of that will happen a little bit faster. It's also quite a cool thing. Good, so this is it with this tutorial. I hope that you liked it, that you learned something new. If you like my content, then please consider supporting my channel. You can either do that by subscribing to the channel, liking the video, but also to check out my Patreon, where you can find exclusive full courses on Houdini and exclusive tutorials. And you can also download the final project files of this tutorial project. So thank you very much for your support. Thanks for watching, and I hope to see you next time. Goodbye.